Hello friends, myself Rajendra Mahajan presenting my video on question and answer. Question number 1, explain how to solve differential equation, how to solve differential equation using Laplace transform. Using Laplace transform. Whenever we have to solve any differential equation by Laplace transform, there are some steps. Step number 1, take Laplace transform of both sides of given differential equation using standard result as per the applicable. Number 1, Laplace of first order derivative is s f bar of s minus f of 0, where f of 0 is the value of that function at t is equals to 0. Second, Laplace transform of second order derivative is s square f bar of s minus s f of 0 minus f dash of 0. Similarly, we have third result, Laplace transform of third order derivative is equals to s cube f bar of s minus s square f of 0 minus s f dash of 0 and minus f double dash of 0 and so on. Then collect the terms of f bar of s in one bracket and transfer other terms to right hand side by using given initial conditions. Step number 2, find inverse Laplace transform of f bar of s as the required solution of given differential equation either by using partial fraction method or convolution theorem or convolution theorem. Therefore, these are the steps to solve differential equation using Laplace transform. Question number 2. If Laplace transform of f of t is equals to 1 upon s multiplied by s square plus a square, then find f of t. Laplace of f of t nothing but f bar of s. Therefore, here f bar of s is given as 1 by s multiplied by 1 upon s square plus a square, and we require to find f of t. F of t nothing but inverse Laplace transform of f bar of s. And to obtain this inverse Laplace, we use convolution theorem. We know that inverse Laplace transform of first function 1 by s as 1, inverse Laplace of 1 upon s square plus a square as 1 by a sine of at, standard result. Out of this, we call this as f of t, and the first one as g of t, say, or we can interchange the terms. Then by convolution theorem, inverse Laplace of the product of two terms 1 by s multiplied by 1 upon s square plus a square is equals to integration from 0 to t f of t into g of t minus u du, and therefore it is equals to integration from 0 to t. In f of u replace t by u, we get 1 by a sine of au, and in g of t replace t by t minus u, we get that term as 1 only, and then integrate this product with respect to u. 1 by a is constant term, we can take outside. Integration of sine is minus cos au and divided by a, limits from 0 to t. It becomes 1 by a square. Cancelling that minus sign by changing the limit, 0 become upper and t become lower. For upper limit, we have cos 0. Cos 0 is 1. And for lower limit, it becomes cos of at. Therefore, this is the required answer. Number 3. Can we solve all types of differential equations using Laplace transform? If not, specify the types. Main important application of Laplace transform is to solve differential equation, and that differential equation is linear differential equation with constant coefficient by Laplace transform. We can solve. This is the type of the differential equation which we can solve by Laplace transform. And non-linear differential equation we are not able to solve by Laplace transform technique. Question number 4. Find inverse Laplace transform of 1 upon s square plus 25. And to obtain this, we take the help of standard result. We know this inverse Laplace of 1 upon s square plus a square is 1 by a sine of at, and therefore inverse Laplace transform of 1 upon s square plus 25 means 5 square, as 1 by a means 1 by 5 sine of at sine of 5t as a required answer. Question number 5. Write a relation between Laplace transform of integral from 0 to t of f of t with respect to t and Laplace of f of t. We know that theorem of Laplace transform of integration, that is Laplace of integration from 0 to t f of t dt is 1 by s into f bar of s, where that f bar of s is nothing but Laplace transform of f of t, and that is the required relation between Laplace of integral in terms of Laplace transform of f of t. Question number 6. Write Laplace transform of f of t divided by t in terms of an integral. In terms of an integral. Again, by standard theorem, we have Laplace transform of f of t divided by t is equals to integration from s to infinity of f bar of s, its integration with respect to s, where that f bar of s nothing but Laplace transform of f of t. Provided limit of f of t by t as t tends to 0 exists. This is the required answer. Question number 8. Write Laplace transform of t cube into f of t using a derivative of Laplace transform of f of t. To write the answer, we take the help of again a standard theorem. We know that Laplace transform of t raised to n into f of t means function f of t multiplied by t raised to n. As per this theorem, it is minus 1 raised to n nth derivative with respect to s of f bar of s. F bar of s nothing but Laplace of f of t. And therefore, applying this theorem, Laplace transform of t cube, here n is 3, into f of t is equals to minus 1 raised to 3 and third order derivative of f bar of s, where what is f bar of s? It is nothing but Laplace transform of f of t. That is the required answer. Therefore, question number 7, find inverse Laplace of 1 upon s square plus 4s. And to find inverse Laplace of 1 upon s square plus 4s, we can rewrite that as inverse Laplace of 1 by s into 1 upon s plus 4 by taking s common, and by the property of inverse Laplace transform, it is nothing but integration from 0 to t inverse Laplace of 1 upon s plus 4 and its integration with respect to t. Integration from 0 to t inverse of 1 upon s plus 4 is e raised to minus 4t into dt as per standard result, and then integrating it with respect to t, its integration is e raised to minus 4t by minus 4, limit from 0 to t, taking 1 by 4 common, cancelling minus sign by changing the limits, upper become 0, lower become t, e raised to 0 we get 1 minus e raised to minus 4t as the required answer.